Welcome to this course in data science. Although the title says Introduction, this is a serious class, more of a broad overview of data science. We assume that you have taken a good number of CS courses to understand some of the technical details that we will cover in this course. So, background knowledge needed. Here are some specific courses that a computer science major might take or have taken to prepare for a career in data science. A course in algorithms, a course in data structures, calculus course, and a linear algebra course, statistics, and the machine learning is optional as we will discuss them more in this course. So what is data science? Let's think about this statement from Hamming. The purpose of computing is insight, not numbers. So we just want to see the insight from all these numbers that might not make sense to us when we look at them. Data science is also a skill for the 21st century because we're going to work with a lot of big data. So that's one of the things that we have to learn how to do. Now, what's the difference between traditional programming and data science or machine learning? So in traditional programming, you would provide a computer with data and a program you wrote, and it provides an output. For example, you might program the square root program that provide the computer the data required to compute the square root. On the other hand, in machine learning, this is kind of flipped. So you provide the data and the output to the program. We ask the computer to find the program. So in machine learning, what the program does is to learn the algorithm, for example. So for instance, we can say we got a bunch of points and we like to fit a curve to these points and find an approximation curve to all these points. So that's really different from you coming up with an algorithm and getting the output versus you providing the data and the possible output and the computer being able to find it. So a computational data scientist, which I believe most of you are, combine computer science and data science to create some interesting thing with computation. So we have big data systems, we have big data algorithms, and we also have complexity of the computational complexity there. There's no one definition of data science. It's really the application of computational and statistical techniques to address and gain insights into problems in the real world. So there's a reality. We collect some raw data. For example, we might say there's a reality of gravity. So we collect data related to this. Data is processed, and then we clean the data, and then we do what we call exploratory data analysis or some visualizations to find out what might we see in this data. So we use some models and methods, and we find reports, presentations, and interpretations, and then we produce a product. So data science, why now? Because we are collecting a lot of data. Google processes more than 20 petabytes of data every day. That includes 3.5 billion search queries and so on. We have better and faster machines. Our CPU are faster. We have GPUs, and we also have TPUs, standing for tensor processing units. We have better machine learning algorithms, such as deep learning with neural networks. Data is the best way to understand problems and find solutions. It's hard to argue with that. So where are the data science opportunities? I would say for those with degrees in computer science or technical degrees, they're in this upper part. You have to have some AI deep learning, experimentation, machine learning, analytics, metrics, and so on. There's also data science jobs at the lower level which may not require a college degree to do. So it's very interdisciplinary, combining multiple areas of computer science, statistics, linear algebra, databases, and so on. And it's not machine learning. It's not machine learning competitions like Kaggle. It's not statistics. It's not big data. It's not mathematics. It's not data mining. In a sense, data science kind of explains the past. In other words, when you have the data, we can try to explain the past by exploring that data and creating different types of models. And then once we understand that, we can try to predict the future. That's the value of data science. So there's a life cycle of data science. We create data, we collect data, we process data, we analyze data, we preserve data, we access data, you reuse data, and we keep going in this cycle. The components of this course include Python, Jupyter Labs, conceptual quizzes, a project, and a final exam. So, see you in class.